Hello everyone, welcome to QRio. In this video, we will be learning about coordinate geometry and more specifically the distance formula. Now, some of the applications of distance formula is in the field of navigation such as the GPS system or the Google Maps, aviation in flight operation. Suppose we want to locate an aircraft in the sky, then we use the coordinate system. In the study of space, planetary motions, and so many other applications are there for this. Now let us define the distance formula in two-dimensional coordinate system. This is a two-dimensional coordinate system because to specify any point we need two coordinates. So to specify any point, if we need two coordinates, it becomes two-dimensional. If we would have needed 3 points, then it would become three-dimensional. Okay, and so on. So here we have 2 points, A, x1, y1, and b, x2, y2, and we want to calculate this distance. Then we use this formula, AB is equals to root over x2 minus x1 whole squared plus y2 minus y1 whole squared. Now let us try to understand the concept with the example. Here we have 2 points A and B. A with 1 comma 1, x1 is 1 and y1 is 1, and B with x1 is 5 and x2 is 5 and y2 is 1. Okay, how do we determine it? Firstly, we go from the origin in the x direction. Okay, this is 1 unit in the x direction, and from here we go towards y. Okay, 1 unit in the y direction. So this is 1 comma 1. For this point we go from origin 5 units in the x direction, and from here 1 units in the y direction. So this is 5 comma 1. So we have these solution x1 y1. Now we use the formula x2 minus x1 whole squared. Now we substitute the values, 5 minus 1, 1 minus 1, it's simple. This is also simple. In case there are negative numbers inside, we solve the negative numbers within the braces and then only afterwards just square it. So this is 4 squared 16, 16 plus 0 is 16, 4 multiplied by 4. So AB turns out to be 4 units, and by units we mean centimeter, meter, kilometer as per the question. And this is the distance AB, and it's quite true also if we check it here. 1 unit, 2 unit, 3 unit, and this is 4 units. Okay, now let us look at the formula in a different way. This is our formula. Let's try to simplify it by squaring on both the sides. We square at this side also and this side also. Now AB, when it is a squared, it becomes AB squared, and when this thing is a squared, you see the root and the square gets cancelled because the root is to the power half and this is 2. Half multiplied by 2 is 1, so it gets cancelled. And now if you look at it, don't you think this is something familiar? And if you are thinking that this looks something like the Pythagoras formula or the Pythagoras theorem, then you are absolutely correct. This is just another version of the Pythagoras theorem. You see, where AB is acting as the hypotenuse, base, x2 minus x1 is acting as the base or perpendicular, y2 minus y1 is acting as the perpendicular or base. Okay, so now let us calculate the distance AB using the Pythagoras model. Okay, we consider AB as the hypotenuse, and with it we draw a right angle triangle. It's fairly simple. Okay, this is 4 unit, this is 1 unit, 2 unit, 3 unit, 4 units, this is 3 units, 1, 2, 3 units. Okay, this is simple. AC, and this is BC, and this is AB. So let's use the formula AB. Again we are calculating distance only. AB squared is equals to AC squared plus BC squared, and then we substitute the values and we get 25. AB squared is 25 and AB is equals to root over 25, and which turns out to be 5 units. Okay, so in this way also we can calculate it. And what can we conclude from these examples is that the distance formula is just another version or the Pythagoras theorem in a two-dimensional coordinate system. I hope you understood it, and in case you didn't understand, you can take a graph paper and try to do these questions. Try to think over it and you will understand it. It is simple and it is elegant, and it feels nice when you discover that. So here are some questions that you can try, and if you get all of them correct, you can congratulate yourself. And that's all. Thank you so much, and do like and subscribe and hit the bell icon, and you can like us on Facebook also and follow us on Instagram. Thanks a lot.